Hey everyone, welcome back to our channel. Today we are diving into an amazing problem that is maximum subarray sum, which is present on lead code itself. So the problem statement is quite straightforward. Like we have been given an integer array and we have to find the contiguous subarray that is containing at least one number. Okay. So which has the largest sum and returns its sum and prints the subarray. So let's go through the example. So we have been given an input array that is -2, 1, -3, 4, -1, 2, 1, -5, 4. And in output we are getting 6, which is the maximum sum of a subarray. Like in this case, the maximum subarray sum will be like the subarray will be 4 minus 1, 2 and 1, which has the largest sum is equals to 6. So basically let's build the intuition for our naive approach, or we can say basically the brute force approach. Suppose we have been given a list of numbers, okay, and our task is to find the contiguous subarray with the largest sum. So what would be our first instinct? I want you all to take a moment to think, right? So basically uh, one obvious way is to check all possible subarrays, right? And we can then find the one with the maximum sum. Sounds fair, right? So I will tell you like how we have to think. Think of it like this. Suppose if I give you 9 numbers, which is there in the array, like 2, -2, 1, -3, and those are the elements. So you could take every possible start and end point and calculate its sum. Basically, we will check every subarray. It's like checking every possible subarray combination to find the one with the maximum sum. Are you getting my point? Basically, we have to start from the starting index, and we have to check. We have to take every possible start and end point, and we have to calculate the sum. So basically we will go through the brute force approach, like what I'm trying to tell you all guys. Suppose we have to select all possible subarrays. I will show you on the table itself, but let's understand what is happening there in this. So we have selected all possible subarrays using two loops, and the starting index of the subarray will be like I, and ending index of the subarray will be j, and we have to be calculating the sum of each array, and we have to use a third loop to sum up the elements from I to j, and after that we need to keep track of the maximum sum found so far, and we have to compare each subarray sum with the current maximum, right? So basically we have to compare it with the current maximum, and we have to update the maxi if needed, right? And at last we have to return the maximum sum found. So let's break this down step by step with a simple table. I will show you all so we can understand it better and in a quickly manner. Okay, so we need to check all possible subarrays and finding the one with the maximum sum. We can see like in this the subarrays are -2, -2, 1, -2, 1, -3. These are all the subarrays, and the sum are there of the subarrays, and the maxi is there, that is the maximum sum so far. So what we are doing is basically like we are checking all the possible subarrays in this, and we are calculating their sums. Suppose in the 0th index -2 is there, so we are taking the -2 as sum, and in the maxi also we are taking -2, and in the first index we have -2, 1. So we can see that if we took the sum of this subarray, that will be -2 plus 1, and then we will get the result as -1. Basically we will update in the maxi too, so it will also become -1. We will keep updating maxi whenever we find a larger sum. Okay, so by doing this process repeatedly, we will reach to a final answer, and the required maximum subarray will be 4, -1, 2, 1, and the final sum of the maximum sum maximum subarray is 6. That is the maximum sum found. Okay, so we can see the, if we talk about the time and space complexity of a brute force approach, so it is quite simple. Like, since we are using three nested loops. Okay, so it is quite clear that the time complexity is O of n cube. That means if n is equal to 1000, we are looking at 1 billion operations. And this is something which is not great, right? So we will now level up. So let me show you something mind blowing, which is Kadane's algorithm, and this is the way we will move towards the optimal approach. And suppose we will be talking about the optimal approach here. So basically, I will tell you guys how to think of a Kadane's algorithm in a simple manner. Like, imagine we are walking along a path collecting coins. Okay, so if we reach a point where your total coins are negative, please be attentive. Like, this is the line which have a deep meaning here. So imagine we are walking along a path collecting coins. Okay, if we reach a point where your total coins are negative, so would you keep going? No, right? So we would reset and we will start fresh in order to be in positive. So that's exactly the idea behind Kadane's algorithm. So let's go towards the intuition of optimal approach. I will tell you all. Like, uh, basically we have what we have to do. Okay, so we will start with the sum is equals to 0, and we will initiate the maxi, that is we will take it as int min. We will initiate it and we will traverse the array, and we will keep adding the elements to the sum. Basically, Kadane's algorithm gives the solution in one pass. We don't, like, unlike the case of brute force solution, we need to use three nested for loops. But in case of this, we need to traverse the array only once. And if the sum is greater than maxi, we have to update maxi. Getting my point? I will explain you in a much better manner. Like, what's happening? Let's go through the table. What we have created is basically, first of all, it is basically very clear. Like, we have to traverse the array and we have to add elements to the sum. And if the sum is greater than the maxi, we need to update maxi. But if the sums becomes negative, we need to reset it to 0. Okay, suppose if the subarray sum is in negative, like -1 or -2, so we just don't need it. We will reset it to the maximum sum will be 0. Okay, so let's go through the table. I will tell you what is happening here. So we, in the table itself, we can see we have index, we have element, and running sum, which will be the subarray element sum, and we have maximum sum also. So I will and I have also wrote down the actions taken, what is happening basically. So you all can look at it from the table itself. We are starting from at index 0, and the sum is equals to -2. So as I told you all, like, if the sum is negative, so we will just reset it to 0, and basically we have to discard the negative sum. Okay, so we will move next. At index 1, we are getting sum is equals to 1. So we will simply update the maxi value, that will also become 1. In index 2, what we are getting is sum goes negative again, that is -2. So it's simple, we will again reset it to 0 because we don't need any negative values. And you all can observe, like, from index 3 to 6, we find the maximum sum. Like, 3 to 6, the nothing new is happening. We are updating the sum, and we are continuing it because we are getting the positive sum, and we are updating the sum if it is greater than the previous one. And similarly, we are reaching to the final index, like, from index 7, you can see the sum drops, but we don't reset it because it doesn't go negative. Okay, so keep in mind. And at the last value, like, we are getting at element 4, we are getting the running sum as 5, and the maximum sum we are getting is 6. So basically this will be the final answer, maximum will be 6. Okay, And if I talk about the time and space complexity of a Kadane's algorithm, which is basically O of n. Okay. So what we are doing it basically we are iterating through the array only once using a single loop. Unlike the case of brute force approach, we are using three nested loops. But here at each step we update the sum and maxi in the constant time, that is O of 1. So the total iterations is equals to n and the time complexity is n. So it will be much faster than the brute force approach. That is obvious thing. And the space complexity will be like O of 1 only, constant space, as we are not using any extra space. Okay. So basically let's go through the code. I will explain you all like what is going on there. So let's go through the lead code interface. So there is a function max subarray, and we are, as I told you, like we are initiating the maxi, that is int min, and we are storing the maximum subarray sum, and we are initiating the sum is equals to 0, that will be tracking the current subarray sum, and we are traversing the array as I told you, and we are adding the current element to sum. After that, what we are doing is basically we are updating the maximum sum if needed by comparing it with the maxi and the sum. Getting my point? We are using max function here to compare the value of maxi and sum, and we will be taking the value of maxi according to that only. We will update the max, and if we are also using the if condition, like if sum is less than 0, the sum will become 0 because we don't need any negative value as we saw on the table itself. So after doing these steps, we will get out of the loop and we will simply return the maximum value. So that, and the maxi value will give the maximum subarray sum. So I hope like I was able to explain it well. If you guys have any doubts, any inputs from your end, you all can put it on the comment section. And if you guys like the video, like you understood the solution, please like the video, subscribe and share it as much